30-2s, we're going to go over these polynomial worksheets. I'll just link the PDF in below if you just want to check to see if you got the PDF right. So we're going to go through and just list off a few of the characteristics of these polynomials that we have here. So the number of x-intercepts, you just read that right off the graph. You can see it crosses twice on the x-axis. I'm just going to put a 2 right there and assume that this thing's not going to jump all over the place. My end behaviors. Now, this one's a bit trickier because you can't really see where the left starts. Remember, you always read from left to right. Left to right. So where does the left part of the graph start? It doesn't actually start in the first quadrant. If you were to extrapolate this back, it starts off in the other quadrant over here. So that starts off in quadrant 2, and then it would run off into quadrant 1. So that's where the end. You can see it dips down into quadrant 4 down at the bottom, but we're just worried about where the ends are, these two graphs. Okay, number of turning points. So it's going down, then it's going up. So there's only one turning point here. Domain. I'll quickly realize that we've done all these before, but the XER is my domain for all these polynomials, unless we talk about real world questions. That's later in this week if you haven't done those assignments yet. And my range here, just look at the min point on this graph here. I got a scale of -2. So the lowest point of my graph is -2. So my graph has to be everything greater than that value. So greater than or equal to -2. Part of this is that, is it a positive function? Now, because it's opening upwards, it's got like a smile face to it. This is a positive function. Okay. And the degree of this, because it is a quadratic, this is going to be a degree of 2. And you can see it has 2 x-intercepts. Kind of gives it a little bit away, but the turning points as well gives it a little bit away. Quadratics are 2. So on this next one here, we can quickly do some of these. Like this is a quadratic. Can't see too much of this graph, but it does have that one distinct turning point. It's a quadratic. It's upside down, so it's a frowny face. So this is a negative graph, which means that its leading coefficient is a negative number. Its domain is XER, and its range, you just look at the bottom, or this is the top part of the graph. So this graph here, the top is at -3. So my graph is everything that's less than -3, not greater than like the previous one, because it's opening downwards. Its end behaviors, it's reading from left to right, starting over here in quadrant 3, it's ending off in quadrant 4. That's a 3 if you don't believe me. And then we've got quadrant 4 here. And the number of x-intercepts, there are none. It doesn't cross the x-axis, so we don't have any x-intercepts. It could have 2 if it went up higher. It could have 1 if it just touches it. I don't think I have one here where it's just 1. No, I don't. Okay. Let's look at this one here. What do we have? We got it. End behaviors, x-intercepts, it crosses once. That's an easy thing. You just look at that. Its end behavior starts off in the top quadrant over here. So that's quadrant 2. It ends off in the bottom left, or right, sorry. So that's quadrant 4. Number of turning points. It's always going down. There's never a part where it's actually going up. So there are 0 turning points for this one. Domain, XER. Okay, range, YER. You see it goes up forever and it goes down forever. So there's no min or max point to this. Like, absolutes. Because of the shape, because of the way I drew this area, you notice that it's going from this quadrant here, it's going down this direction. Because it's going down in that, what we call a negative slope for a linear line. This would make this a negative graph as well. Because there's that little bend in it. It's not just a straight line, but that has a little bend in it. The degree is 3. That's the highest we go in this course, is the degree of 3. This one doesn't have a bend in it, so it's a degree of 1. It's going upwards, so it's a positive. It's going upwards from left to right, so it's a positive slope to that one. The range is YER. Domain is XER. Number of turning points. There's no part where it doesn't. It's always going up from left to right. It never goes back down. So It never changes, it never turns. End behaviors, you can see that starts in quadrant 3 and it ends in quadrant 1. And there's a 1 exit. Cool. So this one here, see what we have. Okay, so we got a typical cubic graph, goes up and down. It goes, has one turning point here, it's going up and then down, then it's going down, then up. So it's technically 2 turning points. Actually, both these graphs have 2 turning points. What are you gonna do here? Okay, so 1 x-intercept for that one. If you look at the one below it down here, it has 3 x-intercepts. Now the end behaviors for both these graphs are the same. They both start in quadrant 3 and end in quadrant 1. Okay, the domain is XER. You notice those are all the same for every of these polynomials. The range, because there's no absolute top to this graph. It goes on forever upwards. We're just going to say YER. And because of the shape, because it starts in this quadrant, it's going up this direction, that's a positive shape to this graph. So it's a positive graph. Okay. Same, this graph is also positive. Its range is also YER. And its degree is also 3. The only thing that changes with this graph that it has 3 x-intercepts. Okay. There's the answer for this one. Hopefully you did well on that. Okay. See you in the next video. Bye.